So let's start off with training.
Sure.
Okay. So are everyone, let's have an introduction. Who else are there in a call?
Okay. Yeah, my name is Karthik. Uh, I'm located in Canada now.
Okay.
So I have little experience on business objects. So and now I want to go with the ETL. That's why I'm preferring the Informatica. So that's about me.
Okay.
Hey, Masud. My name is Rakesh. Currently, I'm in USA.
Okay.
Currently, I'm working as a ETL analyst at Papers VCVS. So I want to switch to ETL Informatica domain in the current company.
Okay.
So
So
that's
so
why,
Rakesh,
yeah,
so you're already working as ETL analyst.
yes.
Okay. Okay. So Rakesh and Karthik. So myself Ankit. So I am a trainer of Informatica. So I have experience of 4 years of being training in individuals training through institutes and through MNCs. So I used to teach Informatica MDM, Informatica data quality. So here we are there to teach Informatica Power Center. So I basically will train you on end-to-end on Informatica from beginning to end, from architecture to the end-to-end each and every components of Informatica. So you excel yourself in the Power Center. So I'm Informatica certified associate, so I know anyone having certified from university for training and all. So,
Yeah.
so before I start up, would like to know Rakesh is already aware of what ETL is because he's already an ETL analyst. So Karthik would just like to know, are you aware of some concepts or before we proceed, let's have a understanding like what is the base knowledge of everyone so we can go hands on hands. So as
Okay.
if I'm not wrong, Rakesh might be already aware of ETL as ETL analyst, so he might be little bit aware of ETL things and stuff, how it works in data warehouse. So
This is my first project, Ankit here.
okay,
I joined recently a month ago. So as a ETL
okay,
analyst, I'm still in learning stage only. So I know what is ETL and what exactly it was, but technically I'm not pretty much strong.
okay. Okay, that's good, Rakesh. You already told me. So, and Karthik, could you please tell me about yourself, like how much you are comfortable level in that?
Yes, thank you. That is what even I knew. What Rakesh said now. I just know the concept of ETL. That's it. I never involved in that. I have just 4 months of experience as a business object developer. That's it. Just only reporting side. So I don't have any practical knowledge in ETL. Uh,
Okay,
yeah, I just knew what ETL is. So just mm, staging and transforming.
okay,
Yeah.
okay, okay. No issues, Karthik and Rakesh. We'll walk through every basic concept first. So that's how the things will move. Let's
Okay.
see. Are you able to view my screen, or do
Sure.
I have
Yeah.
to do
Yeah.
something?
Yes. Yes.
Yes.
Yeah, both Karthik and Rakesh, are you able to view my screen?
Yeah,
Yes.
yeah.
Okay. Uh, so, one more question, like, are you aware of data warehouse? Anything, any Rakesh and Karthik?
I knew the concepts, but uh, I don't know completely about these models. These we have two models, right? Star schema and the other one. Uh,
Okay.
yeah, I don't know much about that, but I knew that there are two models in data warehouse.
Okay.
Yeah.
Okay, fine. No issues, Rakesh. and Karthik. We'll walk through those. So basically, I mean, before we jump into the Informatica, we'll cover few of the basics of data warehouse, and we'll walk through some history of ETL. So how does that evolutions came up, and then we'll directly jump into the Informatica core concepts. So before we go into the core concepts, we'll cover data warehousing.
And before going to Informatica, can you also give some mm, knowledge on SQL concepts?
Okay. So what I mean before we give on
I
SQL
mean,
concepts.
to what extent we use SQL in the Power Center?
Okay.
Yeah. Actually, I don't have much knowledge even in SQL also. I have basic knowledge, but not much, so I would like to know what extent we use these SQL concepts in Informatica. All these things.
Okay.
Also, can you explain about this loops concepts?
Pardon, Rakesh, I did not catch your words.
No, I am Karthik. So,
Okay,
can you
yeah.
also explain the loops concepts in SQL as well?
Okay, loop concepts. Okay.
Yeah, that's what I know up to, but I don't know till what extent we use this SQL in Informatica. So,
Okay.
I will,
I mean,
while going forward, I will ask if I have any questions.
yeah, sure. I mean, feel free to ask any questions, or you can interrupt me in between while I continue on the sessions. Let's to have two way of sessions. Like I start explaining something, you start questioning on something. So that will be an interactive session. So let's have that. So if I start explaining something, if you have any questions, interrupt me, stop me sometime in middle, and let's have a discussion on your doubts, right? Before I go on
Yeah.
continuing further.
Sure.
Sure.
Okay. So, so Rakesh, just wanted to know from your side also, that the same thing should we carry out for SQL concepts, right? Like what all things we needed in ETL perspective, I mean Informatica perspective, what all SQL things we need out here?
SQL things like you're asking about the queries or like SQL concepts. Hello.
Hello?
Yeah.
Yeah, I mean queries and which we need in Informatica, like it will be a normal like joins and all we need inner queries and all those things. So those things will cover as part of this.
So like we'll be covering here like creating indexes or all this point of view as well. Okay. So like I do know few things in SQL concepts like I mean what you said, inner join, outer join, and
I mean,
basically yeah.
yeah, I mean, I'll cover up the things which we needed Informatica point of view. Like we need indexes, and apart from indexes, we need joins.
Okay.
I mean, we won't covering the major point like creating procedures and all, creating functions, as that will be an other part of SQL. So we'll covering that part of SQL which we need as a part of Informatica. Like joins will cover. We'll cover indexes. I mean, indexes creating and all are not required as part of that, but we need to have knowledge because advanced point of Informatica when I'll covering in future sessions, we need indexes concepts before we load data into a table and all. So we'll get to know why we need indexes concepts. So that I'll cover prior to going into the Informatica. We need that concepts because there will be certain issues encountering if we don't have indexes and all. So there are types of indexes which we need. So those concepts are much more required like other transformations kind of thing which we have in Informatica. It's similar like those kind of things we need to have indexes also few things. So indexes is very important. Joins are very important like inner joins, outer joins, those things. So those are very important. Apart from that, SQL concepts is like creating table. I think those also will take up once a glance. So creating tables, inserting a records. So these are the common things which we need as a part of I mean Informatica. So as Karthik already asked a question like how far we need SQL. We need majorly, and I mean SQL we need definitely as a part of Informatica for querying and all, because each transformation what we do is it's some or other way it's an SQL query what we write there. I mean it's not needed of writing. Instead, Informatica provides us a transformation to do that. So as a part of ETL, you said we need, yes, we need SQL. We need to have if you say an SQL of 100%, you need to have a 40% of knowledge on that. Like it's not need of having a procedure functions, that knowledge, but you need to have a knowledge on joins, especially it's very much needed. You need to have a knowledge on indexes. It's very, very important to have a knowledge on indexes when you are dealing with Informatica, because that will help you. I mean, once we go through a session, you itself will realize why we need that. Because when we are dealing with Oracle as a database, you need to have a concepts of these things, because whatever I'm telling, it's related to Oracle. Because if you are related with other database, will compare. I mean, once we do that loading strategy and all, we'll see what are the differences with different database. But we'll go with right now with Oracle, because that needs indexes and all, because Teradata doesn't need that. So that comes with some other features. So I'm just telling it. I mean, just you don't confuse it on later side. Yeah, this is just related to Oracle database. Teradata will have some other things. So with Oracle database, we need a joins knowledge and basics of SQL. Okay, so basics of SQL is that creating table, inserting records. So those things we need into a particular schema and all those things. So those things I'll explain. Joins, inner join, outer join, left outer, right outer join. So those things are needed, and the indexes. So these are the common, basic things. Before we'll start into an Informatica, we will be needing those SQL things. So that I'll cover. Okay, so I think before going into the Informatica, we'll cover the following things. So do you want me to cover anything else, Karthik and Rakesh?
Yeah, thank you. Like, how about from Linux point of view?
Yeah. Okay. So that is one more question. So both of you, I mean, anyone is aware of Unix commands, because that is as important as SQL.
I do have an idea about basic commands. I think so. Not
Okay.
pretty much in depth. So like how to open the file, how to edit the file, up to that kind of knowledge I don't have. How to access server.
Okay. So I'll just give you an. Okay. Yeah. Tell me, Rakesh.
No, I'm saying that I don't have any idea on Unix.
Okay, Karthik. No issues. I'll just give you an overview how far it is used.
Okay.
Unix is used, I mean, as a developer perspective. Why it is used, I'll give you an overview. See, this Informatica tool has a client and a server. So server is installed either on a Windows or an Unix. So it depends. With every project, sometimes it is installed on Windows, and somewhere it is installed on Unix. If it is installed on Windows, we used to run bash script. And if majorly it is installed on Unix, because it is more secure and it has a lot of functionality which we use. I mean, we used to develop a shell scripting and all in Unix, so that is used here. So Informatica server is on Unix, so that's the reason we do a shell scripting and all. So we'll cover basic of commands. Basic commands will cover, and apart from that, one major thing will cover is how to run an Informatica jobs using. I mean, how to run those Informatica jobs will let you know what exactly it is using Unix. So those things also will cover. Apart from the basic commands, we'll cover a few of the basic commands. Then those basic commands will put it into a script, a simple script, a sample simple script. Will develop it, and then we'll see how it is run at backend.
Okay.
So I mean, so before I start up with the concepts, I would like you to know again, SQL is majorly used in Informatica for joins, indexes are there, some basic queries we have to be aware, but majorly not much of SQL is needed, because Informatica provides us a transformation that does a task of what SQL query does. So, but we need to have a basic knowledge of SQL queries, irrespective of whichever database we are using. Next comes is Unix.
Okay.
Unix, we have to be aware of basic commands, because most of the time the source is not a database, it is a file, and we'll have to take the file from another server, FTP it, or we have to put one file to another, we have to do data corrections. So few of the things we make use in Informatica. For that we need to have a basic command knowledge, and apart from that, when we say scripting, Informatica, we need to run a job. I mean, we create some mapping sessions and all, so we need to run those. To run those, excuse me, we have to run that from backend. So backend, when we say backend, it's a server. So server again is installed on Unix. So we need to run a script from a Unix. Using some commands we need to run. Excuse me. So that commands will see how we can run. I mean, when we cover up rest of the things, at end will go to a Unix. So Unix will help us to implement the jobs of Informatica end to end. So once you are done with whatever the front end client tool, when you go to a server, you will run that from end to end, error comes, or all those sort of things. So that is done through Unix. So this Unix will take care, I mean, we'll consider it after the completion of Informatica's concepts and those things, because after that we'll see how the backend, the jobs are used to run using Unix. I mean, after we cover a basic commands, we'll cover up that running through end-to-end Informatica mappings and all. So even Unix is required if we have a server installed on Unix.
Okay.
So, Ankit, I have a question here. So,
Yeah,
like,
yeah,
while you were saying like FTP kind of script, like placing the files, like this kind of stuff. So,
yeah,
coming
yeah.
out there, like, we would be using the file scripting or shell scripting, like, what kind of scripting would we be using?
No, we don't, I mean, we can use those scripting, but we won't use Perl scripting, we use shell scripting. I mean, when we say shell scripting, it's not that big shell scripting we'll be developing, it's just a one-line command. I mean, see, basically I'll just clear it out, the terminology meaning. When we say scripting, it's, see, we learn a few of the basic commands. For example, I'll show you one example here. Okay, let me show you one example. Okay, I just want to list a file. Okay, so this is the simple command.
Yeah.
ls minus lrt. It's a simple command to list my file. Okay, once I listed my file, whichever files are present, I have to copy that entire file into another simple dummy file. So what it will do is, see, ls minus l will list my all files in current directory. Let's say, go to any file like ftp dir. Okay, this is my path where some 5 files are present. You can assume some 5 files are present. So ls minus l, what it will does is, it will list all the files present in my directory. Now what my task is, whichever files are present, I have to copy that files into another dummy file, which will have all the list of all the file names. So this is a simple command that does. Okay, what I mean to say is, if you combine two or more than 2 commands of basic commands, basic like listing, copying, so those small commands will put it into a script. So a script is not generally that will have 500, 600 lines, that will have just 2-3 lines. It's a combination of few of the basic commands, so that will put it. So it's not a major scripting will develop here. It will have only few commands like 2-3 lines, or it may have while loop, or it may have if else. So that's the only thing we'll have it here. It's not the major things will develop here. It will only have the few basic commands. So those basic commands, whatever we learn here, that will put into a scripting, and the scripting majorly will have while loop to run that job continuously based on some condition, or it will have if else conditions. So that's the thing, like it will have 2-3 lines, but totally, yeah, we call that as shell scripting. It will run on any one of the shell, but majorly it will run on conch shell. I'll explain you about those shells and how it is run. But majorly, I mean, answering to your question, excuse me, answering to your question, yeah, we develop a shell scripting by using few of the basic commands. I mean, we no longer to need that advanced scripting knowledge, but we do need a few of the basic commands knowledge for scripting, so that you can put it into a script and we run that.
Okay.
Okay. Okay. So, do we have any questions?
Yeah, and I hear that we also transform XML data. Is that correct? If we do that, then do we also have any XML coding knowledge?
No, we no longer need XML coding language. The way I'm saying is because we do have XML as a source file. I mean, we take a lot of sources like mainframe also one of the sources we take. We have salesforce.com. We have XML as you said. We have SAP, but we no longer need that knowledge. I mean, a small knowledge like other sources, but we no longer need that knowledge because we take XML as a source, we import it into a mapping and we directly do the task. I mean, Informatica itself generates the XML taggings and everything, so we no longer need a knowledge on XML, but we need a basic like those tags we have like start and end and the sub tags. So that is, I mean, if you have knowledge, it's good, but Informatica itself create those taggings. So you should not do anything in that. And I mean, apart from XML, as you said, we have other sources as well, like Salesforce.com. We used to get data. We used to get data from SAP. We used to get ABAP code, and also it doesn't need a knowledge on that because Informatica itself generate those things by its own. So you should not do anything. I mean, we just take care of loading strategy in that case. So that does our task.
Okay.
Okay, so any other questions? I mean, before we start up with data warehousing?
No, you can proceed.
Yeah, sure. Okay. Okay. I mean, before I start up with data warehouse. Okay. Before let me start up with data warehouse. Let me say you. I mean, why exactly the data warehouse came into the picture? I mean, early 90 and 1995, we did not have that concepts. I mean, the market doesn't have the data warehouse concepts. So why it actually came into the world and what exactly the changes it did. See, initially we did not have any data warehouse concepts in the market. All the things were done using either Excel or the databases. We had a complex databases. We had a mainframe systems. We had a lot of other systems through which the system was moving on. We never had data warehouse in that earlier age. But why exactly it came? I mean, before let me start off with data warehouse. I'll give you a simple example how the things came up, how the data warehouse came up. We'll take a simple example of a Colgate company. When the Colgate company was running earlier stage, it had its market in entire Indian market. We'll take India as an example. Suppose we'll consider 4 zone: east, west, north, south. Its market there in everywhere. It was launching its product on everyday basis. I mean, every day or every monthly basis, it was launching product in every different regions: east, west, north, and south. So its product were there everywhere. after that business, what they realized is they didn't see when we think any technical concepts in business perspective, what exactly they needed. They always need their revenue to grow, their industry to grow. An industry can only grow if your revenue is growing. So that the same concept holds here as well. So okay, we have took the Colgate example. So Colgate products are there in entire India, east, west, north, and south. So now business came up. I mean, initially when you set up any industry, so we have only targeted zones like east, west, north, and south. Okay, so then next the setup was they wanted to have separate state wise like Karnataka, Tamil Nadu, Delhi, Rajasthan. So they inquired each state wise. Each state wise each state wise the Colgate was grown. So each state wise the business was getting report like, okay, Karnataka is getting that much revenue, Tamil Nadu is getting that much revenue. So this totally, whatever I am saying is totally was achieved using the databases and few of the Excel things also. When I say Excel things, it's just to calculate the total revenue, and the reports were built on that basis previously in earlier stages. So that's totally done using a databases. Next, what happened is business started growing more and more rapidly in 2000s and all. They wanted city wise. I mean, they wanted a revenue calculation based on the city basis, like how much Bangalore is giving, how much Chennai is giving, how much Delhi is giving the product. So the databases started became more and more complex. We reached the level of third normal form of architecture, if you are aware in database. So databases started become more complex. Stored procedures were being developed because that time we did not have much ETL concepts, much data warehouse being used. So the procedures and all started developing more and more complex. So what was the other promise? When we move from state to city, again the same procedures went in depth. Lot of problems, lot of ambiguity started developing into the procedures. Lot of technical enhancements were needed to do replication of that. But as a business point of view, we reached a level of city basis revenue calculation, and business is able to understand which city is getting. I mean, suppose see, we'll go to Colgate Max Fresh is one of the products. So that is getting sold in Bangalore. That is getting sold in Bangalore more compared to a Chennai, where we have a Colgate family product that is getting sold. So that type of information business started getting it. But now business became more, and I mean when 2000 onwards, I mean 2003 and 2004, business started changing rapidly, and the competition among the competitors started changing. So business wanted a data that can give us not just a city but area in a city. If you consider a Bangalore, it needed a different area like Majestic, Chickpet, and different area wise they needed which product is getting sold maximum there and which is not getting sold, so that they can give discount offers. For example, the same example I'll take Colgate Max Fresh and a family product. So what they started is the area where bachelor people are there the Max Fresh product was getting sold majorly, because that cost some 32 rupees, and the family product that was 60 to 70 rupees, that was getting less sale in those areas because their bachelor people used to stay in that area. So what they used to do is for family product they put an offer, so the revenue get generated, so people start thinking of buying those products as well. So those things as a business point of view started coming from 2003 2004 onwards. So there comes the evaluation of data warehouse. When you need in-depth analysis, reporting, and detailed analysis like which product is selling, so that time we came up, the father of data warehouse who founded data warehouse, Ralph Kimball and Bill Inman, those people's ideas started implementing in real world when this kind of analysis was needed in all the industry. I just took an example of the well-known industry, but all the industry needed in-depth knowledge of customer, what they exactly want, and they wanted to understand their customer. That was the first thing, and they wanted to generate a revenue based on that. So that time the data warehouse came into the picture when they wanted a detailed history, detailed analysis of each area, so they can generate an offer and they can excuse me, they can send those particular products to their respective area and they can give an offer. Because earlier what was the issue is they were giving an offers to the area where people already buy that product. So it's a loss for a company, because if you are giving a product for 60 rupees and people are buying for 60 rupees, and if you give an offer to the same area, then it's of no use. I mean, company will go under loss. So those things started coming as a business point of view. So to understand the customer, what they are buying, or what to give, what kind of products we need to give, that came the building of data warehouse. That time it says, wow. Then the business says, wow, that times, yeah, this is the time when data warehouse came and we did analysis, and that helps the business to grow and also help the customer to enhance their buying quality. They started getting offers in different areas. So that started the building of Royal Data Warehouse started. So when data warehouse started, now the thing is we have to set up rest all things, right? So to set up the rest all things, then the ETL concept started. The ETL does that task automatically. So instead of doing everything stored procedure, ETL simplified everything. It started giving bulkier transformations, simple transformations that does your task of SQL long, that huge SQL procedures of 5,000, 10,000 lines of coding was done using a single transformations. So 5-6 transformation can do your 600 lines of coding. So simply that reduced the load of technical as well. We needed 20-25 developers. That came to 5 developers of transformation, ETL. So that came the evaluation of ETL as well, and the corresponding reporting and everything. So that started the building of data warehouse when the business wanted detailed analysis of each area, how we can grow our business. That is a simple example I took. I mean, it's not related to Colgate company or something. It's just a simple example I took as a point of data warehouse. So that took an evolution of data warehouse. Okay, so that took an evolution of data warehouse into the market.
Okay.
Okay. So any question? I mean,
no. Okay.
Okay. So I mean, before I start up with the technical bunch, I just really thought to give a very good example. Okay. Yeah. So before we start up with the technical concepts of data warehouse, how it is used, and what exactly the meaning of that data warehouse, I just thought of giving a real-time example, like how exactly it's used in practical world before we jump into that data warehouse. Okay. So as I said, I mean, it's now basically for business point of view, it's a revenue because it understands its customer and in which area he does an analysis. So that's the analysis. When we say the word analysis, we does, and that's how the things are moving up. So that's how it's. Okay. Generally when we say a database system, generally when we say a database system, like we have an ATM machine. Okay, we have an ATM machine that is actually it's on database system. I mean, it will hold a transaction. Like whenever you go to an ATM machine, you swipe your card, you put some amount, you withdraw it. You can see maximum of your 5 transaction. I mean, last 5 transaction receipt you can get. I mean, last 5 transaction. Suppose if you withdraw some 500 rupees, 1000 rupees, you can view that. But you can view only up to a last 5 transaction. More we can't view, because that is the only excuse me, because that is the only data present in that transaction system. So when we say a transaction system, okay. Okay, when we say a transaction system, like as I told you, ATM machine is a transaction system. When you go to a ATM machine, swipe a money, so that's the only information it holds. It holds the information of last 5 transactions, because that database can only hold your last 5 transactions. It can't hold your entire set of history, like when you opened your ATM account and till now, how much transaction you have done, how much money you have withdrawn. And it doesn't tell like, okay, you withdraw most of your money on your shopping, you withdraw most of your money on online shopping or groceries. It doesn't tell you anything. When you go to ATM machine, it doesn't tell, boss, last month you have did that much online shopping, so most of your money goes in online shopping. It doesn't tell you all those things, right? It only gives us the small information of last 5 transactions, because that is a database. So that ATM transaction, what we call it, it's an transaction system. So in a technical terminology, we call in a technical terminology we call OLTP. So those systems are called as OLTP. So those are excuse me. So those are transaction systems. So those transaction system, for transaction processing, we call it as OLTP systems. That gives us only idea of your transaction system, not other than that. So suppose as a customer you want to know whatever the transaction till now you have done in over your credit card, will say. Suppose whatever the transaction you have done, you wanted to know that where the most of the money has been used. So you need an analysis of report. Okay, shopping has gone that much. I mean, in the month of March, the shopping has become increased. In April, over the groceries, it has increased. So that is what analysis we say. We need a system has to do an analysis of that. So analysis system. So okay, analysis system we call it as OLAP. So we have here 2 systems. One is for transaction processing. Sorry. Okay, so transaction system, when I say, it will only have the transaction set of record. So that is needed for your transaction processing. See, for ATM we doesn't need an analysis processing, right? Because if you go for analysis processing, what will happen is, to withdraw your amount, it will take an half an hour of time, because it will analyze previously where it went, from where what cash is coming, how much amount of analysis, I mean how much amount of shopping you have done. So it will analyze all those things. To get your amount back, it will take half an hour to processing, because analysis system is always bulkier, that will hold your history records. So it will always take a lot of time consuming, but it does analysis. So when you say data warehouse, it is an analysis system as well as OLTP system. So whatever the transaction things is there. Hello. Hello.
Yes, Ankit. Go ahead.
Yeah. Okay. So whatever the transaction system is there, that is OLTP, and whatever the analysis system is there, so that is an OLAP systems. So when you say data warehouse, it's an analysis or transaction, it's a both. So where we need to do an analysis, so that data is stored in another warehouse, and wherever the transaction system, I mean a transaction data is needed, I mean only a few set of record. So see, it always, whenever, I mean, it's just a, a hint, which I would, just a tip, I would like you to give. It's like, suppose, anyone asks you a question like, a data warehouse is an analysis or a transaction system. It's actually both. A data that needs an analysis to be done, those are stored in an analysis, OLAP. I mean, when we say analysis, it's even an history is stored along with the current data. And sometimes we doesn't need a history records. We only need a transaction record, few records, like 2-3 records for my processing. So that's the only requirement of a business. So that time we store that data into an staging system, staging area that will only hold records of 4 or 5 records. It won't hold my entire history of my own history. It won't store. It will hold only records of 4 or 5. So that is a transaction system. So sometimes we need transaction system as well, and many a times we need an analysis systems as well.
So we store both transaction data and analysis data in a single database, that is data warehouse.
See, when we say data warehouse, we don't store transaction system. It's like transaction system. It's like truncate. I mean, we store it for 1 day. Generally as a practice point of view, we store transaction data for 1 day. And analysis data that is stored for a longer time. It's an history. It's never get deleted. But transaction system, yes, we do store in the same database, but it's same database with different schema. You can think like that.
Yeah.
So that will be stored only for a day. Okay. When I say only for a day, it's depend on a business point of view. Because when I said an example of ATM, there the business says that we need a last 5 transactions. So you have to store that amount for last 5 days.
Okay.
But generally we don't go to any system that has more than 5 days, because once your database become bulkier, your example fails. ATM amount, we withdraw amount within 5 seconds. So within 5 seconds or within 1 minute you can withdraw your amount. But if that system become bulkier, suppose if business gives you a requirement that I need 25 to 50 transaction history and all those things, your system become bulkier. If your system become bulkier, the customer will face a problem of withdrawing your amount. It will take very longer time, 10 minutes to withdraw amount. So customer satisfaction become less there. So that time transaction system will not have history records. So that is the real time example. Like it won't have a history records. It will, maximum it can have is the last 5 records. So that is most. But transaction systems are like truncate system. Today you load a data, preserve it for an entire day, so people can use it. Tomorrow again a fresh record will jump into that table and the previous records will be deleted. That will be a general transaction system in data warehouse. But analysis system, data warehouse, which will have dimension facts, that system data will never be deleted. It will have all sort of history. So when I say history, it will have duplicate records and everything, but how will identify a correct data and duplicate data, I'll let you know, I'll explain you in future classes. But general example, analysis system will hold all sort of records that will have all your history. From the time you are doing any transaction till something like 25 years, 50 years of records, or any organization that was set up in 1850 and 2014. So till now, whatever that organization has done, all that data will be present in that warehouse. So that is an analysis. That warehouse will be used for analysis, reporting, and everything purpose. So that is a major intention of OLAP. And when we say transaction system, even that has to be managed, because we can't say that always we need an analysis, because there are few things for that we need. Business doesn't need an analysis, it changes. Once data is loaded, we need an answer to that data. We need a transaction on that data or immediate processing within a minutes of time. So that time we say it's a transaction system.
Okay.
Okay. So Karthik and Rakesh, before I jump into the theory concepts of data warehouse, I was through an example of where what are used. An organization example I gave you to relate how data warehouse came and where we make use of it. And if you want, I can give more example as well. If it is not clear, and I give OLTP example, transaction processing of ATM machine, where that is particularly used. So any doubts on that? Example. I have still not went into the definition of what data warehouse is and what exactly it is. I will just do an example so that you guys get clear about what data warehouse exactly is.
I am clear about it.
I mean, you are not sure about those examples?
No, I'm sure. I'm clear about it.
Okay.
I understood.
Okay. So let us move forward.
Yeah, I can go ahead.
Yeah, sure. Okay. So we came up with two very good examples that illustrated us the data warehouse things. So okay. So now we'll go to the some technical things about data warehouse. I mean, this was just a general abbreviations. Whatever I told you till now, it was just a general knowledge regarding the data warehouse things. But now we'll go to some technical things about data warehouse. So when we say the word data warehouse, it is actually a historic data, as I told, OLAP system. So that will hold your historic data. I mean, and as I told an example, like from 1850 to 2014, any organization has done whatever the changes. So all that history of records will be present in data warehouse. So anytime you can go to database and check its history. So that will hold all the historic data. So that's a warehouse actually. Okay. So when we say data warehouse, its actual definition is the one which I'm saying right now in technical perspective. General knowledgeally, we can say it's a historical system that will hold all sort of history about an organization or about whatever the products, single product that is getting sold in a market from past 15 years. So that will hold history of that, how much that product is got sold in which country, what are its revenue being generated in that country. So it will hold all sort of history about that particular product as well in data warehouse systems. So that is what a general definition, but actual technical point of view, the data warehouse definition is it's divided into four things. Like it is usually a subject oriented and integrated, time variant and non-volatile. That is what the data warehouse definition is. We'll see, I mean, example wise what exactly it is that. When we say data warehouse, it's a subject oriented. I mean, when we say data warehouse subject oriented, uh, we generally have, I mean, suppose if we take a product, I mean, as we are taking example of products and all, we'll have a customer, we'll have products and all those things. So when we say customer and product, a customer is nothing but a customer database. If you see, it will have all the details of customer. When you say product database, it will have all the products of that company are getting, I mean, whichever products they are selling, all that information will be present in a database, and the table is called. When we say product, it's nothing but that database present in any one sort of schema. So that will hold all the info, that table will hold all the information of that product. When we say customer, customer is a table, a database present in that. In a database, one table is their customer that will hold all the customer of that particular organization that are taking, I mean, making use of those products. So let's assume we have that particular organizations have customer and product. So will that particular customer, all sort of information are present inside that. So that will call a subject. So your subject is nothing but that particular customer, product and all those things. So what we do is when we load data into a warehouse, we load it from each subject wise. Like customer is a subject, product is a subject, like that operational and other systems we have. So we are loading, if you can see my screen, we are loading data from customer, we are loading from product. So it's a subject oriented. We load data into a warehouse. I mean, when we say warehouse, it's dimension and facts. I'll cover that part as well when I deal with data warehouse in further concepts. We load data based on subjects. I mean, initially we ask to have a customer placed into our warehouse, then we'll place a product. I mean, it's a sequence. You can't, I mean, we can load product as well, but product table again will have a customer link to that. I mean, are you guys aware of that primary foreign key relationship?
Yes.
Okay. Are aware, right? I mean, a table that has a primary key, and that primary key will have an associated foreign key in another table. So in that case, are you guys, can you tell me, like, see, I'll give you an example. Like I have a two table, customer and a product. Customer key is a primary key and its associated foreign key is present in a product table. So can you guys tell me which table should be present first and which table should be present second?
It's a customer table should present first.
Okay, perfectly. So that is what is expected. Primary key, whenever it holds, that data has to be present first so that the foreign key can make a relation. It's like a primary key is like a big brother and foreign key is like a small brother. His big brother has to be present there, then his small brother can take the data from it. It's like that. So your customer table has to be present first and then your product table. So the primary key, whatever things are there, has to be loaded first and then the product. So that's good. That's good thing. We need to have that concept is very important in database. We need to have that referential integrity between primary and foreign key, otherwise data will not be loaded. And even you can't delete a data without having that integrity knowledge. So that is very good knowledge. Okay, so here we comes to again a subject oriented. When you say customer and a product, they are the two different subjects. So in warehouse, when you say warehouse, it's dimensions and facts. So two different attributes of functions. We have it in data warehouse. It's a dimension and a fact. So when we load into a dimension tables, it's a customer subject and a product subject. So we load it subject wise. So data warehouse is a subject oriented. So data are loaded by subject. So data are loaded with particular product basis, particular customer basis. So that's why we call it that as subject oriented. So data are loading basically based on subject. So this is the first function. I mean, first, when you say data warehouse concepts, we say it's a historical. It will hold all the history data. So that is the one thing. And second thing is it's a subject oriented. So data are loaded based on each subject. So that is the first definition. I mean, when you say definition, this is the first thing. Data warehouse is a subject oriented because it loads data based on subjects. Customer is a subject, product is a subject. Next, a time variant. So one very good thing about data warehouse is whichever data it loads, it stores the snapshot of that data. I mean, if any of you might have not got the opportunity, or if you get an opportunity to build your own data warehouse, what exactly we do is we create a snapshot. When I say the word of snapshot, it's the same snapshot like in a mobile you are browsing something and something, if you like it, you take a snapshot and store that into your mobile memory for the further use. It's the same thing. In data warehouse, what I create is, suppose whatever the data I'm loading, I take a snapshot of that so that I don't lose it. So I take the snapshot and I store it into my database. So I take a snapshot of those data. So that's make me sure that yes, whatever things are getting loaded, the snapshot are. So whatever the per cycle is, I mean per loading, like suppose I'm loading 10,000 records at a time, I'll take a snapshot of that. Suppose in most of the times what we do, we go to google.com, we used to serve many sites. And suppose if I like some few of the things, I take snapshots so that, you know, I like those things, I remember in future, I can buy those products or some website I can go through, I take a snapshot of. That's a similar thing in data warehouse as well. We take a snapshot of every data being loaded. And, you know, in a particular cycle, we used to load 10,000, 50,000 records. It's based on the amount of loading we have. So we take snapshot. We'll cover those things, what is that snapshot and the two different types of loading we have it here. That will cover, but as of now the snapshot is generally the word which captures a data. Okay, so next comes is data warehouse is a time variant. So when you say a time variant, so data, so see, when we say time variant, so data includes, I mean data are loaded on timely basis. See, for example, today you are loading some data with some specific date. Tomorrow again you will load the same data with different date. So that two records will be identified as two different records in data warehouse. Whereas in our transaction systems, it will overwrite it. I mean, it will update the older record with a new record. So if you go through data warehouse and if you curious on tables, you will see same record present hundreds, 200 times. So data are present time variant. If times are getting changed, so for the different times the data are present. Data was formed from 2000 and now it's 2014. You may see 14,000 records which different years, different date, and different times. So that is what the time variant says. So data warehouse will hold history records based on different intervals of time. Whereas in our transaction system, how it was working is we always used to update. But in data warehouse, we do never, this is a very important thing. In data warehouse, we never used to update our tables. We always used to insert that. We never used to update because we have to preserve history. So that is the main purpose here. Time variant, when we say, we store all the history records of the same customer, same ID with different time variant, different dates. Based on different dates, we identify which is the latest record and which is the older record. So based on that latest current date, we identify this is the latest record of that customer and we pick up that. So data warehouse is a time variant because it will hold all those records based on different times. Okay. Next is very good thing about data warehouse. When we ETL point of view, it's a very good concept. When we say it's an integrated, next word is after subject oriented is done, it's based on subject. We used to load data. Next was a time variant. So history is preserved based on different dates. And next very good data warehouse concepts is it's an integrated. Okay, majority of a system, I mean, if you go to any industries in the market, we used to have third-party system. We used to have a Java front page tool, online tool from where we used to get a data. Many systems we have. See, we'll take on HR system like here sex is male or female, payroll is 1 or 2, product management 0 or 1. All three basically means the same, but they are written in different way. See, suppose if you are online form you are filling it, you can select from a drop down. So that is the best thing which we have. But if you go to a third party system which they used to hand written and all, because even those source system we get it, but that is in a text file. So they are not sure about what means what. They may feel, I mean, at their system they may follow 1 as male and 2 as female. So that way they can follow. In some way they follow 0, 1. So it's everywhere different. So data has to be integrated. So when data loads into a data warehouse, it should follow some integration. So that logic we define it at ETL side before loading into a data warehouse. But here concept is data is integrated. However, we get a different data, we convert into some standard format which we follow at our end. So that is done using ETL. But when we store data into a data warehouse, it is M/F because that is what the common we follow. Some business may tell you to, I mean, whatever the data we are viewing at this side, you convert it into M. I just want the full form of that, male and female. So even whatever the data you have got, you can convert into a male or female. So it's basically, the data has to be integrated. However, different data you can get, you have to convert into some standard format which business used to tell us to follow and store data into a data warehouse. So that is very good concepts of data warehouse, ETL. The data has to be integrated. Otherwise, for same data, if you view different things, it's confusing. End of the day, the result will be 0 when you are reporting side. So that's the very good example. Data warehouse has to be, I mean, it has to be an integrated system. And the one last foremost thing about data warehouse, it's a non-volatile data. Means the data is not volatile. Volatile means evaporates. Data doesn't evaporate from data warehouse. The data is always stored. We preserve history, and data is never lost. Once the data goes and stored in dimension tables, data warehouse, so data will never get lost. It will always be present. So we never lose a data from a data warehouse, but we lose from operational system after 1 day, 2 days, or maximum 5 days, how much ever is the requirement. Generally, in the data warehouse point of view, operational system will only hold the data for 1 day. So if you go to second day, that data will not be present, new data will be present. If you want to see the older data, we have to go to data warehouse and start querying a system. So it's a non-volatile. So data doesn't evaporate. When you say volatile, it's an evaporation. So data doesn't evaporation, data doesn't lost. Data is always preserved. So if you can see, you can load data and you can read data. Here we can do create, update and all those things. So that thing we don't do in data warehouse. We don't do update. We just insert data. When we say loading, it's an insertion of records. I mean, it's a data warehouse concept. It doesn't. It's not like a different database that if you find an update query, it wasn't updated. It's not like that. We can do that, but in data warehouse, we should not do updates. We should only insert the records. Once the dimension tables are created, after that we have to do only insert. If you write an update query, it can be done, but it will be locked generally, because data warehouse suggests that we should never update, because we have to preserve history. And there is a logic to understand previous records, I mean older record and a newer record. There is a logic, I'll come to that, but that's what the data warehouse says. It's the concept. So it's a subject oriented, where data are loaded based on subjects. It's a time variant, so data's histories are present based on different intervals of time. It's a non-volatile systems, and data are integrated. So these four attributes make a definition of data warehouse. Technical perspective, these four attributes makes a definition of data warehouse: subject oriented, time variant, integrated system, and non-volatile. So that's what the data warehouse comes. So this is what the data warehouse is. Let's take a simple example. Okay. See, if anyone tell you like how many matches we have, within how many minutes you can identify like how many matches you have? Hello?
It takes some time.
Yeah, it takes some time, right? So this is how our database is. Database, we always go on storing data based on unique primary key, always go on storing. So it takes time, right? We can't, within a lapse of time, I can't calculate how many sticks are there, matches are there. How early you can calculate here? Yeah, this is our data warehouse. Systematic arrangement of everything. You are storing everything perfectly. It's just not like primary key or go on inserting unique key, your data is this is how we store in database. Just go with unique primary key knowledge, you store everything. This is not the thing. This is how the system we arrange. How superbly the system is. If I tell a small children, he will calculate within a second and he will tell that how many sticks are there. That's how the business needs, that's how the reportings are done, that's how the ETL also needs. So that's how the loading strategy and the technical point of view, we need a data to be systematic arrangement of a system. Systematic integrated systems, we can say, basically. So that is how we want the system to do. So this is how what we are achieving using warehouse system. Totally analysis system. Hello.
Yeah.
Yes, sir.
Okay. Okay. So that's how the total system is. So are you understanding the? Are you able to understand the basics of data warehouse? Till definition.
Yeah.
Yeah.
Okay.
So I have a question, which is Rakesh. So like before you
Yeah,
say
yeah.
we do need to load the data into the database, but we don't need to update the data. We do have an insert strategy, but there is no update strategy, you would say. But my question is like,
Okay.
if suppose if a customer is there, like suppose you take one company and there are like 100 people in that company. So if that 100 customers are there, like they will be registering with the address and additional things like contact numbers and everything. So initially he registered with one address and one phone number or whatever it may be, and like after a month he changed his address or his contact number. So at that point of
Okay.
time, like how we may handle that kind of situation?
Okay. So yeah. Okay. Very good question. Okay. I was about to go to that example. It's a valid question. We'll go with same situation. Customer, generally we know that people used to change from one place to another. People used to change number from older numbers to a new number. These two are majorly changes happen onto our database whichever industry, whichever system he goes, you will observe two changes for sure. It's the phone number and it's an address. So how we store those kind of data into a database, as we are sure that we doesn't need to do an update on that, right?
Yeah.
Okay. Okay. We used to insert those records. How we used to do is, we'll show you one example. Okay. Okay. Are you able to view my screen?
Yes, Ankit.
Yes, sir.
Okay. We'll take example of. I mean, right now I have this. It might looks a little bit complex. Let's try it. You can see the primary key 3, right? John Freeman.
Mhm.
Okay. John Freeman was initially residing in Bangalore. I mean, when he gave the address, actually it's not fully written. It's Bangalore, 555 Avenue. So state Karnataka, and active date. I mean, this date, insertion date and update date. So your update date will be the same as insertion date. Here actually one more column will be there. That is called a flag. We will have one more column called as flag.
Mhm.
Flag basically will have only two values. One is Y, that means active, and one is N, that means inactive. So for any particular customer, we will have only one record with Y and will have multiple records with value as N, because all its previous transactions are inactive. So we'll flag it that to N. So that is the only place where we do an update. We update that particular flag with Y and N. That too on, I mean, that too not on dimensions, I mean data warehouse. We do that as staging only. So when we cover that in Informatica, will let you know how we used to update that particular thing. But as of now, flag, active, current record, N means older record, inactive record. So for right now, okay, right now we'll consider 3 examples. Assume like all the 3 are fresh records being inserted into our dimension table. So all the 3 are fresh records, so all will have Y, 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 correct?
Yeah.
Okay. Next time, John Freeman is Bangalore. Now he got transferred to Hyderabad. So what we need to do is, we have to change his address, city and state. So John Freeman record is updated based on Hyderabad, Andhra Pradesh. Okay, and the flag, the older, I mean this doesn't have everything actually. Older, we'll have 2 records for John Freeman. One record with John Freeman, 556th Avenue, Bangalore, Karnataka, then a flag N. And we'll have another record with John Freeman, 556th Avenue, Hyderabad, Andhra Pradesh with flag Y. So that flag Y tells us that this is an active record, and the flag N shows that this was the previous record. So basically we are not updating the existing record. Existing record we are keeping as it is, but we are updating its flag to an N, making it an inactive record. And we are updating, I mean we are inserting a new record with flag Y to indicate it's an active record.
Okay. Then my question is like, if next time if someone come and ask like let me pull present customers in our company, so at that point of time like will it be coming both the records with the name John Freeman, or like only the record will be coming only the active record?
Yeah, this is also a very good question. See, when we go to a data warehouse and when any customer or anyone says us to query a John Freeman on any customer, query should always have a where clause where it says a flag is equal to active. Why? Okay, we should never query, because if you query, your query will take a hell out of time if you want to extract all sort of records. But generally it's a very rare case when any particular customer, any malfunctioning or anything has happened, we need to figure it out even his inactive state. That is the only time we go for both active and inactive records. But in terms of reporting or in terms of ETL things, whatever we implement, we will always have a where clause where we says flag is equal to y, because we will only extract where it's active. I'll give you an example why I'm saying only active. See, you go to any industry, I'll take you an example of insurance industry. Customer policy has to be active before we do anything. Before we send him an offer or before we tell him that is a golden customer or anything, his policy has to be active. The policy has to be active, that flag has to be a Y. If we send a flag N to on that discount offer, so inactive customer also will get a discount. This is a real example how insurance used to work. We generally for discount we always used to prefer, okay, for discount we always used to prefer active records. For active, the record has to be in a flag Y. So always wherever data warehouse system or wherever real system, wherever the ETL warehouse is used, we'll always find a where clause where it says a flag is active or flag is equal to Y.
Okay.
So is it clear? I mean, we'll go to that scenario, how this thing is practically done. We'll go to that. But as a concept point of view, this is how it works. I mean, it might be healthcare industry, insurance, anywhere. We always used to extract a record which is active. Inactive records we are no longer needed until and unless some analysis you are doing on an older customer. But general practice, we always used to extract record which is active. So that is activity we identify using a simple word flag. We'll add that column flag, and based on that we do that.
Okay.
Okay, is the concept clear? I mean, how does that works?
Yeah, it's clear.
Okay. Okay, so that was about data warehouse. Okay, so data warehouse generally have schemas related to that. We have few of these schemas. I mean, see, initially we had architecture of first normal form, second normal form, third normal form of architecture we had, but later those architecture became much more complex. So that data warehouse came. Okay, so when the data warehouse came, it came with a very simple architectures. We call it a star schema, snowflake schema, hybrid schema. Those terminologies started coming. So what exactly are those basically? When we say star schema, what exactly it is? So before I go into this, let's have something basic. Let's have something. Okay, when I used the terminology of data warehouse many times. Okay, okay. When I say data warehouse, it is nothing but two things. It's a dimensions and a facts. When I say data warehouse, loading data to a data warehouse, doing analysis, all those things. When I say data warehouse, it's nothing but a two tables, a dimensions and a facts. So why we need two things when we can achieve using one thing? How that complex database structure, how the data warehouse is simplified is by using dimensions and the facts. They are nothing but two tables. Now the question is, why we need these two tables? What is the purpose? Why we need that? Let's see why we need that. Dimension is basically a raw data. Like previously I told, for customer and product subject I took, like it holds all the customer data, product will hold all the product data. So raw data, when you say, it holds all the detailed information about the customer. It will hold all the detailed information about the customer or product or whatever table you take it. It will hold detailed information about everything. So that is nothing but dimensions. Dimensions will hold all the detail in raw data, all the detailed information about your customer, about your product, about anything. Whereas fact will hold measures. What measure means? It will hold, suppose you have a table that has sales data. Now fact will hold, fact will hold measures. Measures means sometimes the first difference is dimension will have every, like we'll take one example of sales dimension. Okay, it will hold all the records of sales from starting to end. It will hold all the raw data of sales, detailed description of whatever the sales happened on the particular product and which are the customer who took those. So those are our data, all the sales dimensions. So that will have a primary key. Sales ID will be something like a primary key. Okay. Now facts will hold that sales ID as a foreign key. In a fact table, along with that it will have the sum of sales based on product. I mean, I'm just taking an example. When we say measures, it will have sum or total amount of sales, anything, any aggregated values you can say. That why we need that is, generally when we do a reporting or whenever we are dealing with other stuff, we need those aggregated values like sum, total. So that thing, what it does is it actually reduces our time. See, whenever any table has that some aggregated values calculated, see, generally if you want to do any calculative steps on particular table or on a particular column, it takes a lot of time. Instead, many architectures suggest that if we have that aggregate values in our table, it actually reduces our reporting time. It actually reduces our loading time because that value is already present. Just we need to select that and put it into another table, or just select it and show it into a reporting side. So that is another advantage here. We always store an aggregated. Hello.
Yes, sir.
Okay, good. I mean, I just thought that it lost. Okay. Okay, so we'll store aggregate value. So there is nothing but a measures we always use to store in a fact table. So dimension will, just a simple thing to remember, dimension will always have a raw data. It will have all the history of particular sales, and when we say facts, it will always have a associated foreign key of that associated foreign key present here, which is associated with the respective table primary key, and it will have a measures, a sum of something calculated there. So when I say data warehouse, it's a dimension and a fact. So now let's see how it is aligned. So we have broadly two major schemas present here in data warehouse. One is a simpler star schema. It's when we say it's simpler, it's not as simple. While designing point of view, we have to take care a lot of things. I mean, if you go to any of the projects, most of the projects still have star schema, because even through that schema, it's very simple, and you can do most of complex projects you can design using the simple star schema. It looks simple, but it can do a lot of things for you. Let's see what it is. See, it has a fact table associated with different, you can see different dimensions. So again, I'll come to the point. Store dimension will hold all the store raw data here. All the customer dimension will hold all the customer data. Product dimension will hold all the product data. Time dimension generally will hold time and all. So all this table will have entire information. Now fact table will hold all the keys: store ID, customer ID, product ID and time ID. So now question is, see, generally when we had third normal and second, we were in customer dimension, we wanted to link with time dimension. So we used to go through customer ID, then check with its product ID, do a join. Then product ID had a time ID, then time ID used to join with time dimension. Am I right?
Yeah.
Okay. So that was queries were getting more and more complicated in that structure. So now the star schema is simplified. So no longer need to go to each and each dimension to find out the joining matches and get time ID. We can directly go to fact table and gets the linking. Customer ID present in a fact table, time ID is also present in fact table. So we can go to fact table and jump to any table whichever you want. Is the design simplified? Hello? Yeah. So now the design is very much simplified. We can go to just one table. I no longer see, previously we used to remember architecture and lot more things. Now my only thing is, if I remember a fact table that has all the keys, I can do anything. I can go to any table whichever I want. I no longer need to remember any key, which is a primary key present in that table, which is a primary key present. I no longer need to remember anything. I can just jump to my fact table and I can get the data from any table because all are linked to my fact table. So this is nothing but a star schema. It is in star format and a fact table associated with that. Let's take one example as well. Okay, this is one of the example. The same example. See, we have product dimension, we have location dimension, time dimension, and organization dimension. So, are you able to view that properly?
Yes.
Okay. Now you can see my example. See, product dimension identifier is a primary key here. It's a foreign key here. Similarly for respective time dimension identifier, time dimension identifier, location dimension identifier, location dimension identifier, organization dimension identifier, it's present here. So all foreign keys are linked with respective primary keys. So that is how the star schema is formed. Single fact table is associated with all the dimensions. When we say sales dollar and all those things, the example which I took, it's for sum of something it has calculated here. That is basically a measures which we have in fact table. That is for reporting and all purpose. The fact table used to help us by giving an aggregated values. So all dimensions are associated with respective fact table, and how beautiful it is. Just go to one table and get all your tables data. No longer to do a lot of 3-4 joins, 5-6 joins to get my data. Just go to fact table, take any key and join with whatever table you want. It's just a normal inner join. A normal inner join will be present. A basic join, inner join will be present. Do join with any fact with any dimension and get the data. How simplified the database it's going to be now with help of the data warehouse. Simple. This is the example. This is the simple star schema. That just to remember, it can have as many as dimension. There is no limit. It can have generally it will have 10 to 15 dimensions, or maybe 5-6. It depends on which organizations we are building it out for. Generally it will have n number of dimension. As a definition of star schema, it will have n number of dimension but only one fact table. It will not have many fact table. It will have only one fact table associated with multiple dimension tables. Okay. So any doubts on star schema?
No.
Okay. So next is snowflake schema. Now first we'll think is why I have to learn snowflake schema, why it is different from star schema. That is the first question, because here also I have one fact table. Then what is the difference here? Why I need to do the snowflake schema? See, suppose what happens is you have a fact table with associated dimension tables, but what happens is if a dimension table has to associate it with another dimension table, like for any product table you need when that product got sold, what is the timing details you need. So you need to do a join with a date dimension table. Basically you have to do a join with date dimension. So in that case, two dimension table will be associated. Basically a lookup kind of things when we say. So this is an example of snowflake schema. See, for location we need to do a join or lookup, we say basically in ETL point of view. So in that case we need a data from other dimension table as well. So for location we need a state as well. We have country details but we don't have state details, we have city details. For that we do a dimension join and then we link with fact table. So here basically when a dimension, all dimensions are linked with fact table, but there are other dimensions like 1, 2, 3, 4. These 4 dimensions are linked with their parent dimension, but they are not linked directly with the fact table. So when there is a relationship between dimension to dimension, that time we go with snowflake schema. This is generally we go for date dimension when we need a corresponding date for that particular product, or in other concepts. I mean, this is actually a product, I mean a project specific when we don't have a state in that. We have city, country and all. We don't have state, but generally we may have that state as well. But generally dimension is linked with dimension. In majority of the cases it's date dimension. For that particular product we need a date as well, when that product got sold, all those things. So that time at dimension is linked with dimension. Now can you think of why this dimension is not linked with fact table? Because we can achieve the same thing, right? Can't this be achievable? I mean, why can't we make, why we want to learn again snowflake schema? Why can't we make this a star schema? Why can't we link this dimension table with fact table? Can anyone guess that?
Because of the relation.
See, if I link this with fact table, I can build a very good relationship. Why we simply again want to complicate our warehouse? Why we want another schema? Okay, this is just to keep in mind that if we link with fact table is generally a table that is very much bulkier, that will hold a lot of data in real time. If we link any dimension table with fact table, indirectly we are increasing a load on a fact table. We are increasing one more attribute on a fact table. So that we have to reduce in future. We always has to have limited set, whichever are needed for majority purpose. See, dimension which we has to be linked up with one table, that only for that purpose we have to use it. We should not link up with fact table unless and until the same dimension has to be used by all 4. If we don't have that purpose in mind, we should not create an extra column into a fact table. Indirectly it will reduce the query time, performance time and the load time. So only those columns has to be present which are needed. If that date is particularly needed only for particular dimension, we have to link with that dimension only to simplify our load and simplify our architecture. That's the simple reason. So is it clear, snowflake schema?
No.
Okay. So should I? I mean, are you sure about? I mean, are you comfortable in data warehouse concepts now?
Yes.
Yes, Ankit.
Okay, so when we say data warehouse now, you are totally sure about what exactly it is and how it does.
Yeah.
Yeah.
Oh, okay. So that was just an basic about data warehouse, like how it does. So before we jump into an ETL concepts. Okay, I mean before we start up with any ETL, basically what exactly is the ETL is it's an extract transform load. When we say it has a meaning actually. Extract, why it is ETL, why it is not ELT? Because there are some product in the market, we may call it as ETL, but they are ELT. Okay, there are many products like Oracle Warehouse Builder. We have Talent, we have Ab Initio, we have Informatica as a major. Many things we have. We all call all tools as ETL. There are some products those are ELT, but many of us call ETL. It's actually just not terminology. It has a meaning behind each product. Informatica we call it as ETL. The reason is like when we say ETL, E means it's an extract. We used to extract the data. When you say extract data, it's either from a database or from a flat file or mainframe system or XML files. Anywhere we have to extract data. So I mean, extracting data is nothing but the extract. The first word of ETL signifies. Okay, okay, extract. Next is transform. After you extract the data, we apply a business logic. After you extract the data, we apply a business logic using any of the ETL tool or using Informatica here. We apply all the business sort of logic before we do a loading. So that transformation means applying a business logic basically. So that is done using ETL tool. So all business logic is applied second. After extract, second thing is to apply a transformation logic. That signifies the abbreviation of the word T. Next is L. After you apply business logic, we dump that data into a database. So that is called a loading. So ETL here is extract, transform, load. First we extract data, then we apply business logic, and then L. L indicates a loading. Few of the system we say ETL, but they are ELT systems where we extract, load, and then we apply a business logic, and then again we load. So there are different in that, but Informatica it's an ETL systems. Extract data, apply business logic, and then load the data. Okay, so that was an ETL. So I mean, before we start up with Informatica, okay, before we start off with Informatica, let's rewind some history. I mean, of ETL. See, I mean, we'll be covering Informatica 9.5.1. Do you want me to go through some I mean some history of ETL before we directly jump into the 9.5?
If it is necessary.
I mean, it's no longer necessary. It's just an.
If it is necessary to know the difference between the previous version and the current version, then we shall do it now.
Okay, I mean, it's no longer needed. But as I'm not sure, I mean, any industry will not have that 9.5.1. It will have previous version as well. So I'm not sure in your case. So we can directly go to 9.5.1, right? So do you want me to go with other as well? Because somewhere we have older versions as well, and some companies we have newer versions and like that.
Yeah. So, while working with ETL, can you explain few transformations in other versions also, previous version and few transformations in current version?
Transformations are, I mean, see, when you say other version is like transformations are same. When the versions migrate, few of the new transformation are added. See, from 8.6 onwards, 8.1, 8.6 onwards, whichever the transformations we have, it's the same till 9.5.1. The transformation point of view, we don't have much changes. The only changes we have is an architecture point of view changes. I would just like you to know that Informatica and Ab Initio are the two biggest ETL tools in the current market. Okay, ETL was not that when it was 5, 6 and 7. Those kind of thing, we had a client server architecture. So that time ETL was not that much strong when we were in 5, 6 and 7 versions of Informatica. But when the Informatica 8 evolved in this world, we had a service oriented architecture. So Informatica started working using services on a services. For a best example I would like you to give, before I tell anything. See, Informatica initially was on server. When we say Informatica or any tool was on server is when we do an installation of Informatica or when we do anything, we need to have a dedicated server to run the Informatica. We need to give 2 GB of space. We need to give that 512 MB of RAM. So that was a dedicated resource we've given to an Informatica to run. Suppose in that server we have Java as well, Eclipse as well. So that also will take some amount of time. So in that time, what used to happen is both the tools were not used to run because Informatica was on server. So when it's actually a very good terminology, which is very superb to know. When we say it's to run only on a server, it means that it need a dedicated amount of resources. So that time that was a little bit drawback because if your business doesn't have that much amount of storage on your system, you can't run 2-3 systems at the same time. Due to that, what was happening is you can't install 2-3 Informatica on your same machine. Informatica servers. Why we need that and how it is running now, I'll let you know. Informatica 8 onwards, it became service oriented architecture. It means that you doesn't need a dedicated resource for that. When you are using Informatica, it will take the amount of resources it needs. It won't take a dedicated amount of RAM or dedicated amount of storage. It will only take, like say if you're, the best example is, okay, you are calling it from Vodafone, right? If you, even those are service oriented architecture. Nowadays in the market everywhere we see a cloud or service oriented architecture everywhere. How exactly? If you want to use some services, we pay for that. Otherwise there is nothing. You can go to that network, do anything. If you use that service, it means you are using their bandwidth. Then the Vodafone will charge for you. The similar way, the similar thing happens in the real world as well and with Informatica as well. If you install that Informatica server on your machine and if you use that Informatica, it will take that dedicated, it will take that particular amount of storage, particular amount of services you are making use of it. So it will take particular amount of RAM and particular amount of usage, particular amount of space it needs. So it's totally a service oriented architecture. So based on services it takes. So when we say service oriented architecture, from Informatica 8.x to till now, it is a service oriented architecture. Okay, so previously we had that other architectures, client server architectures. Those were server oriented, but now we have a dedicated services oriented architecture.
Okay.
So it's totally a service oriented architecture now we have. We basically no longer are dependent on a particular servers on that case. When I'll go with the detailed description of architecture, I will totally explain you where server and services and what is the huge advantage Informatica has taken as a part of service-oriented architecture, and why it is trending in the market, and how it has changed the world, how it has changed many industries to switch to Informatica for their loading part. Because previously in European market we had a data stage going to 4-5 years back, but now entire European UK market has been shifting to Informatica because of the service-oriented architecture and the flexibility it has provided. I'll walk you through entire services. What is the advantage of being in a service compared to a server? So there is an advantage being that. When I'll explain you a detailed architecture of that, I'll walk you through each and every part of that. So you'll get to know what are its advantage as an Informatica services and how it provides. So so basically we will cover Informatica 9.5.1. One more thing I would like you to know is, before Informatica 9.x journey started, till 8.x it was client. After 8.x it became service-oriented architecture, and before 9.x Informatica was stand-alone product. When I say stand-alone product, it means it was only for ETL perspective. It was only used for ETL perspective. There was no other purpose it has. Informatica was only used for ETL perspective. There was no other purpose for that. This was the architecture of 8.x, 8.6 and all. It was a standalone product. It doesn't have anything to do with other things. So this was a simple architecture it had. So the same architecture holds good for others as well, 8.6, 9.1 and 9.5. But 9.5, there is from 9.x onwards, Informatica is no longer Informatica is no longer a standalone product. There is something called Informatica data quality. So even that architecture has been clubbed into an Informatica 9.x onwards. So you'll always see a ETL tool, along with that a data quality tool features inside your product. So when we install Informatica 9.1, 9.5, 9.6, we always have a two set of things. One is ETL tool and one more is Informatica developer tool. So that developer is nothing but Informatica data quality tool. So it's a package now. In that package we get two tools now. So that particular architecture, it's for both Informatica Power Center and Informatica data quality. So it's not a standalone tool, it's a package of two tools now from 9.1 onwards. So architecture, there is a big difference from 8 to a 9 and from 9.1 to a 9.5. So we'll cover in detail services, its architecture, and its major difference about the architecture in the subsequent classes.
Okay. What is the advantage of this data quality tool?
So it's a different thing. Just for an info, whatever you are viewing in my screen, whatever it's in blue color, it's an ETL tool, that is an Informatica Power Center, and whatever you are viewing in a green color, it's nothing but an Informatica data quality tool.
Okay.
Architecture is one package, but we make use of same services which Power Center uses. Advantage point of view, it's a data quality tool. When we say it's a data quality tool, ETL, it's always for extract, transform and load. We use for loading, and data quality tool is enhancing your data. Means, for example, I'll give you a simple example. Suppose there is a name called John Freeman. I'll give you a simple example to illustrate what is the data quality does. It enhances your data actually. Suppose my data has a name column called John Freeman. suppose I am getting data from three different source system. Okay, one is something like John Freeman, second is something like JHON. I mean, some have entered in the wrong way. So instead of John, it has came JHON. Even pronunciation point of view, even that is right. And third one, if you go John Freeman, even that is right. It's no longer pronunciation wise. All the three are pronounced as same as John Freeman. When you load data, which one is correct? So those kind of data quality, data enhancing, we have to perform. So that is what basically is performed using Informatica data quality tool. So in that case, out of we even get all the three records, but we'll load only those two records also will be rectified. I mean, we'll correct it because the first one is correct, valid record. So we'll even if we get wrong data, we'll correct to an correct data using Informatica data quality. I mean, this is just one sort of example I gave, but it has huge. I mean, that is a huge like Power Center. Informatica data quality is a huge tool that enhances your data quality and loads data. It's a huge picture in this market. It's a current trend. And it's a huge thing about Informatica data quality as well. I mean, totally both are different things. It's for ETL tool, that is for data quality. It's for enhancing your data and load data. It's for basically profiling and all things comes. So it's a total. I just gave you a simple example. Like if you get this kind of data, how you rectify it and load a good data. So if you see that example, John Freeman, one data was good and other two were bad records. How we corrected the bad records and into a good record. So those things basically we cover in data quality, and there is a lot more of things. I just gave you a very simple example.
Okay.
Okay. I mean, it's like how you're learning Informatica Power Center. Informatica data quality is also a huge platform and a huge wide of scope in that. So we'll do as well. So okay, so any doubts in today's class? I mean, anything which comes up, like basically we cover data warehouse. I mean, if you want more things in data warehouse, we can cover as well. I mean, dimension facts.
These dimensions and facts, all these things will take care by data analyst, right?
Hello.
Yeah, all these dimension tables and fact tables, these things covers by take care by data analyst, right? Uh, we just have to transform and load. That's it, right?
Yeah. As a developer point of view, we just load data into dimension first because that holds a primary key, and then its corresponding fact tables because that is the foreign key later part. And rest all part, I mean, the designing of that dimension and facts will be taken care by data architect. Data warehouse architect will be taken care for designing a data modeling that we generally make use of Erwin tool. Erwin, who is the father of data warehouse, he has his own tool called Erwin. So we build a modeling, a data model of, I mean, whatever the star schema, snowflake schema I showed you, they build a model in that, the dimension and facts. So that is all taken care by data warehouse architect. They build a model for you and they gives you like this many amounts of dimensions we have, this many amounts of facts we have. The only task of developer is to use Informatica ETL tool and load it to the respective dimension and facts. The design architect point of view will be done by data warehouse architect of designing dimension and facts. As you said, analyst, there is a different meaning of analyst. We don't have here, it's in data quality we have the analyst. Like you can view in my architect, there is something called Informatica analyst. So that it's a different meaning. I'll explain you when I touch this architecture. But here as an ETL point of view, all dimension facts modeling will be designed by data warehouse architect. He is the sole responsible of designing of modeling, dimension, facts, relationship, everything. Physical, logical model, whatever we have, it's all taken care by data warehouse architect. Okay. Anything else you want me to ask? I mean, answer anything like on data warehouse point of view or ETL tool?
No. Up till now, I'm okay.
Okay. Okay, fine. In subsequent class, I'll take up that why Informatica is a major leader and why all industries are preferring Informatica as a major tool. I'll cover up that as well. Okay, why it is majorly used in trend, and we have other very good tools, Ab Initio, Talent. Why we are not using those, and why Informatica is majorly used in all the industries. What advantage Informatica provides compared to other tools. So that also will be covered as a part of architecture and how it does. So I'll cover those as well.
Sure.
Okay.
Okay. Okay. Okay. So shall we wind up for today?
Yeah.
Yeah. Okay.
Oh,
Thanks.
yeah.
So, can we have sessions even on weekends also?
Yeah, I mean, yes, we do take classes on weekdays and weekends as well,
Okay.
but I'm not sure how it is planned for you.
Yeah, yeah.
I'll ask Masood once, I mean, how he has arranged.
Okay.
So you want me to cover Informatica 9.5, right, majorly? I mean, both Karthik and Rakesh.
Yes, Ankit. I think that most of the companies right now they're using 9.5 version. So I
Okay.
think none of the clients is using 8.6 or 9 versions right now. So what I heard from most of my friends or colleagues who works in
Okay,
ETL, they are working with the 9.5 version. I heard.
okay, because even I mean, I have migrated it because even I make use of 9.6 as well.
Oh, okay, 9.6. Okay. I mean, the latest
Okay,
version I heard is 9.5.1.
okay, because I have just now installed that 9.6 as well.
Uh-huh.
So okay, well, I mean it's not much difference. I'll just go through the difference. But as a developer point of view, I still says you that from 8.6 to 9.6 there is no much difference. 8.6 to 9.6 there is no much difference in Informatica developer point of view. Those are the same transformations which we had. It's the same thing. The only difference is the architecture point of view. It has changed many things actually. It's a lot of things has been changed architecture point of view, and functionality point of view a lot of things has been changed, but as a developer transformation point of view only the lookup one thing has been changed and the rest of things. But as we 9.1, 9.5 and 9.6 9.5 onwards, that big data Hadoop and all I think you might be aware of, so those things are added in 9.5. So it's compatible with Hadoop system. I mean, you need to have connector and you can work with big data as well with Informatica 9.5.1. So that integrations Informatica has provided. So those kind of changes we have. Functional point of view changes, I'll go through those changes once we understand the architect basically. Then we can go through those. So I'll cover those as well. No issues with that. But as again developer point of view, which we primarily focus, we don't have much changes going to it, but we have other changes. So we'll walk through the functional changes between till now the 9.6 we have, right? So we'll walk through the 9.1, 9.5.1 those functional changes. 9.5 onwards, the big data changes, big data Hadoop and all are integrated with Power Center. So that's the huge things Informatica has taken up. So we can have Hadoop integration, we can have big data integrations, we can work through a lot of things in Informatica now with going forward. Even YouTube plugin and all have started. I'm not sure if the projects have started or not. YouTube plugin and all have been started. I mean, the currently one in which I am going through is YouTube plugin. You can get data from YouTube and do a lot of functions on those videos and then load a data. Even those things are started from 9.5.1. A lot. I mean, Informatica has grown huge in that sector. We'll walk through those. Let's see how it goes. Okay, I mean these are the services and all which I was talking. I mean which you can see in video. I'll walk through each and every services which I mean you are able to view in my images. Yeah. These are the images, different services we have, and this is how it looks when you configure it. So this is the admin console. I'll walk through those tools and those things in later classes. These are the different services which you can view in my image actually. Architecture point of view, integration, or following services. I'll walk through which are the services required for Power Center and which are the services we have for data quality. Because when you install, you will have all the services. Because right now my tool has all the services, and I have both on data quality I used to work and Power Center. So that's both the things I have it in on my server. So that's how the services are there. Okay, so whatever the image, I go through it.
Okay.
Okay. So
And also,
if you have any questions, yeah.
Is there any possibility to do a small live project, something like that, creating a small data warehouse?
Creating data warehouse, we can go through it, but we have to do it using we have to do it using Erwin tool and all. So I have to figure it out all those things. It's not as it's not as simple, but just if you know the knowledge and if you get a chance to work on Erwin, we have two tools nowadays. Some people use. Let me open that.
No,
Get an idea.
Yeah, sure.
Yeah,
But I think
it's on my.
what my intention is that not creating a data warehouse. I just want to do some real-time thing. What ETL developer does.
Okay. Real-time things on Informatica or on data warehouse?
Informatica.
Okay, yeah. That definitely we are going to cover. We are just not covering the theory part. Theory part just was for till we cover the architecture. Okay, once we are gone through an architecture, this is the Informatica tool. This is the Informatica 9.5.1 where we'll cover everything. Okay, till now, I was totally focusing on more example, because if I just cover theory, it will some or other day it will go out of anyone's mind, because we can't capture a lot of theory in our mind. So I went through those Colgate and ATM machine examples, so that at least for sometimes you do remember those examples and get the definitions. Those things and real time and all. So yeah, once we done with architecture, we are just going to cover the practical things. For every sort of transformation I explain, I'll implement here and I'll showcase. That is what my intention is. Just not to go with theory stuff. Theory stuff was still now the data warehouse concepts, and might be to next classes those SQL concepts I'll cover along with Informatica architecture. So till that time we'll have the theory concepts till we cover architecture and all. So we have to explain those services and all, and we'll go to tool overview once what all tool does overview. Where what functionality, and once those things are covered, I think in next session we will get covered, and later we'll just start with practical concepts. We'll design all transformation. Each and every transformation will implement in Informatica, and we'll see how does it works and what are its basic functionality and what are its advantage. Why it's so popular? Why Informatica is so popular? Why its transformation are so helping Informatica to grow? So those things basically we'll cover as we'll design each and every transformations here basically and see how does the functionality work. So we are just not covering the theory stuff. Theory stuff is only data warehouse, because there I just can't show much of them, because it's again a new concepts of it will again take 20-30 hours, because generally I take design of data modeling and all, so that is other things. But when it comes to Informatica, I'll just cover the few basic concepts of data warehouse, SQL concepts and architecture. So till that time the theory stuffs will be there with some sort of examples, and once I start with Informatica, it will only have those practical concepts of each and every transformations, and how that when Informatica runs, how that whatever the theory concepts I have told, how they are interlinked. So that time you will realize that whatever the theory I explained, how it can be utilized it now. So whatever the services I'll explain, again while running Informatica, I'll link you with those theory questions. I explain you some services, how they are interlinked. So when I run Informatica, when I design a transformation, again whatever the data warehouse, dimension facts, whatever the architecture, whatever I'll explain you, how they are linked. When I create a transformation, what is the backend services are doing? Are they sitting idle or are they doing something? What if they are doing something, what they are doing? How they are understanding I am creating transformation. So those. So let me cover up the theory part, And then when I'll do this, I'll explain you like when I do something, how my whatever the theory part I got, what they are doing, how they are reacting. So those things I'll cover up. So few basic things are needed. So that's the reason some theory parts are going on. After that, when I start with practically, I'll interlink with theory concepts, so you'll get much more easier when we start designing it. So that will become, because now when I might be explaining you architecture, it might not look that much simpler or may not be able to understand. But when I go with the practicality of Informatica running and all, so that time I link with the services. These services react when this runs. These services react when this is run. When shell scripting are run, these services used to react. So that time you will understand your architecture in more superior way and more particular way when we design.
Okay. Yeah.
Yeah.
So nice talking to you, Karthik and Rakesh. So we'll get back to you. Okay.
Sure, Ankit. Yeah.
Sure.
Thanks.
Yeah, sure.
Yeah. Thanks for your
Okay.
time.
Yeah, sure. Yeah. Thanks. Okay.
Ankit,
Yeah. Yeah.
so I think you're recording the session, right? So could you?
Yeah. Yeah. Sure.
Okay, okay. Yeah, we can discuss tomorrow.
Okay. Fine. Yeah.
Yeah,
Okay.
thank you.